दिख नहीं रहा वो अभी। हाँ अभी आया, दोनों में वो दिख रहा है, एक में वो दिखे एक में अपन दिखे।
नीचे वाले में ये जो
वो दोनों में दिख रहा है ना, एक में अपन दिखे ऐसा नहीं होता है। चलो ठीक है, एनीवे
जब आप जब होने तक मैं आपको फिर कर दूं फ्रेंड
कोई बात नहीं, अपन चलने दो यही। यस, दिख रहा है सबको? आर यू एबल टू सी प्रदीप? यू कैन, ब्लर है, ब्लर है, पर मेरे को तो क्लियर दिख रहा है यहाँ पे अपने।
मोबाइल की स्क्रीन पे देखकर हो सकता है छोटा दिख रहा है, इसलिए वो वर्ड समझ में नहीं आ रहा क्या लिखा है।
तो एक टुकड़े टुकड़े में करके देखो, कर दिया इन्होंने यहीं पे, ब्लर दिख रहा है उनको। हाँ ठीक है चलो। अभी थोड़ा इधर करना, हल्का सा इधर, क्या वो इधर वाला कट रहा है। हाँ बस 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 बस, अब तो ठीक है भाई। प्रदीप तुम लैपटॉप पे हो मोबाइल पे हो?
सर आज मोबाइल पे ही मैंने ज्वाइन कर दिया, सर लैपटॉप में कर रहा हूँ।
मोबाइल वालों को नहीं देखेगा।
मोबाइल वाला तो आएगी तो छोटा दिखेगा फोन से, तो मोबाइल से कुछ है, मोबाइल से दिक्कत आएगी। लैपटॉप पे तो प्रॉपर है, यहाँ पर भी
दुबे दुबे अभिजीत,
यस सर।
काय पे हो तुम, मोबाइल की लैपटॉप?
मोबाइल पे।
अरे अरे अरे, क्यों भैया मोबाइल पे कैसे एमटेक सीख लोगे रे?
उनका क्या होगा जो मोबाइल पे भी नहीं?
वो तो कुछ नहीं होगा उनका, उनका कुछ हो ही नहीं सकता।
बहुत सारे
जिनका हो सकता उन्हीं को बोल सकते हैं अपन।
बिल्कुल सर।
चलो जल्दी से बताओ मुझे क्या है।
दिखा सर।
किसको दिखा? अभिजीत को? प्रदीप को दिखा? किसको दिखा? कौन बोल रहा दिख रहा है? आवाज नहीं
दिख रहा है।
प्रदीप दिखने लग गया।
यस सर, शेल्स और फोल्डेड प्लेट्स।
पढ़ो।
ये सर क्लासिफिकेशन ऑफ स्ट्रेस्ड स्किन सरफेसेस।
क्या होता है स्ट्रेस स्किन सरफेस मींस?
सर जो जिस सरफेस पे सर जो स्ट्रेस्ड होता है
वेरी थिन सरफेसेस, हाँ, subjected to stress only, no bending, nothing.
Yes.
These are called, they are two types, shells and क्या है दूसरी?
सर शेल्स जो है सर ठीक होते हैं और सेकंड है फोल्डेड प्लेट्स।
हाँ shells and folded plates। क्या देखा है किसी ने shells and folded plate? देखा है क्या कभी?
सर एक वो दिल्ली में देखा था सर, लोटस टेम्पल बना हुआ है वो।
And folded plate?
वो भी देखा है। देखा हुआ है।
देखा हुआ है कहाँ पे?
तो ये तो कई स्ट्रक्चर्स में देखा फोल्डेड प्लेट्स।
इंदौर में भी है इंदौर में नेहरू स्टेडियम में है फोल्डेड प्लेट्स। जिसने नहीं देखा वो जाके देखे, है ना? ओके, नाउ सो इन आवर कोर्स इट इज shells only, folded plate is not, because the subject is theory of plates and shells. But in why they do not cover the folded plate, I don't know in the syllabus. So shells, so you write down, it is a curved straight surface. You write down the definition of the shell. Shells, it is a curved stressed surface of small thickness it is a curved stressed surface of small thickness compared to radius and other dimension. Means thickness is very small as compared to radius and other dimensions.
Yes, sir.
Now the shells are two types. कौन कौन से हैं प्रदीप? ये टेबल आ सकती है एग्जाम में बनाना. डेवलपेबल, सिंगली कर्व डेवलपेबल एंड डबली कर्व.
Yes, sir.
नॉन डेवलपेबल. नाउ अब ये कैसे दिखाएंगे? स्क्रीन बोर्ड, इसका स्क्रीनशॉट ले लो पहले. क्या?
ले लिया कृष्ण.
So radius of curvature. Then you write down the definition of the Gauss curvature, GAUSS, Gauss curvature. एक जना रिस्पॉन्स देते जाएगा भाई.
Yes, sir.
Gauss curvature, product of two principal curvatures, 1 upon R1 and 1 upon R2 at any point. Product of two principal curvatures, 1 upon R1 and 1 upon R2 at any point on the surface of the shell product of two principal curvatures, 1 upon R1 and 1 upon R2 at any point on the surface of the shell is defined as the Gauss curvature. हो गया गॉस कर्वेचर.
Yes.
For singly curved developables, the Gauss curvature is 0. And membrane equation is parabolic. It is a doubly curve. Singly curve is like this. Singly curved shell have one of the principal curvature is 0. सिंगली कर्व में क्या है, कौन सी 0 हो गई पिक्चर में?
RX R2
RX, यस RX 0. कैसे 0 हो गई? यहाँ तो इन्फिनिटी लिखा है. कर्वेचर क्या होता है?
1/R
Yes, yes, 1/R is 0. So one of the curvature is 0 is called the, so table में भी देखते जाइए, है ना? So singly curved developable Gauss curvature 0, membrane equation parabolic. Then shells of revolution, conical shell. Conical shell. These are obtained when लिखना है ये shells of revolution में conical shell example. These are obtained when a plane curve is rotated about the axis of symmetry. When plane curve is rotated about the axis of symmetry. कौन सा plane curve rotate हो रहा है? Who will tell? Which plane curve is rotating?
Y rotate हो रहा है.
This line is rotating along this curve.
Yes, circle.
Along this curve, this line is rotating, so it is generating the conicals. So these are obtained when plane curve is rotated about an axis of the symmetry. Then shells of revolution. नहीं अभी नहीं. हाँ यस, शेल्स ऑफ ट्रांसलेशन है. सेकंड वन इज द गॉस कर्वेचर 0 वाला. सिंगली कर्व्ड शेल चल रहे हैं अभी. शेल्स ऑफ ट्रांसलेशन. cylindrical shells, including north light and butterfly shells. Cylindrical shells including north light and butterfly shells. Clear?
Yes, sir.
There are the number of cylinder, and this is the butterfly. north light shells. We put the glass here in the factory, so the light comes directly in the inside the factory. So, no need of artificial light in the daytime. North light shells. And the butterfly is another. Cylindrical shell, north light shell, and this is the butterfly. You might have observed the bus stop. Bus stop. It is like the two wings butterfly shell.
Yes, sir.
So, cylindrical shell you can write these shells, these are the shells. These are the shells in which cylindrical shells I am. Conical का लिख लिया था डेफिनेशन. कोनिकल शेल का मैंने लिखाया था डेफिनेशन. लिखा कि नहीं? कोई बोलेगा?
When plane curve rotates, rotates the axis
हाँ
of
इन्हें लिख लिया ना. यस. नाउ द सिलेंड्रिकल शेल्स, these are the shells in which the generatrix means moving curve, and the another is the directrix, DIRECTRIX, और generatrix में GENERATRIX, generatrix. These shells are shells in which the generatrix means bracket में moving curves, or the directrix, the stationary curve, is a straight line. For cylindrical shells, the common curves used are the circle, semi-ellipse or parabola. Circle, semi-ellipse or in this case, the moving curve may be like this, cylindrical shell. Okay? And this is the another curve, stationary curve is this and moving is this. आ रहा है समझ में?
yes, sir.
Yes.
So, these are the shell in which the generatrix means moving curve, or the directrix, the stationary curve is straight line. For cylindrical shell, the common curve used are the arc of a circle, semi-ellipse or parabola. Now, butterfly shells. A butterfly shell is a form. You have to write the definition and figure individual with the definition figure like this in your notes. Now, the butterfly shell, a butterfly shell is formed when two parts of the cylindrical shells join together. Two parts of the cylindrical shells join together at their lower edges. A butterfly shell is formed when two parts of the cylindrical shell join together at their lower edges. These types of shell is commonly used for railway platform and bus shelters. This type of shell is used for the railway platform and bus shelter. Then ruled surface. Ruled surface. These are the surfaces which can be generated. These are the surfaces which can be generated entirely by a straight line, entirely by a straight line if at every point, if at every point a single straight line can be ruled, at every point single straight line can be ruled, the surface generated is termed as the ruled surface. The surface generated is termed as the ruled surface. Common example of singly ruled surface are the cylindrical shell and conical shells. Cylindrical shell and conical shell. क्या लिखा? You read it. Read. Ruled surfaces.
Ruled surfaces which can be generated entirely by a straight line. If at every point a single straight line can be ruled, it is termed as ruled surface.
Yes.
Examples are cylindrical.
So here,
and conical surface.
yes. So here is the single straight line is ruled along this curve,
Yes, sir.
and here also in the cylindrical shell, if we ruled straight line along this curve, it generates a cylindrical shell along this curve. If we rule the line along this curve, if we rule the lines. Understood? So, 3 are completed. The singly curved shells, there were 3. Pradeep, you go to the table.
Yes, sir.
Singly curved shells developable. You read.
Sir, shells of revolution, shells of translation, surface to surfaces.
And ruled surfaces. Ruled shells of revolution, yes, shells of translation and ruled surfaces.
Yes, sir.
Then the second classification is the doubly curved non-developable. Doubly curved non-developable.
Non-developable.
In which there are 3.
Yes, sir.
Now you can write little. Any surface which can be developed is called the developable surface. Any surface which can be developed is called the developable. Means singly curved was the developable and this doubly curved is non-developable. All singly curved shells are developable surfaces. Any surface which can be developed is called developable surface. All singly curved shells are developable surfaces which have a tendency to develop under favorable condition of the loading, under favorable condition of the loading. Equation s square minus rt is equal to 0 for developable surface. S square minus rt is equal to 0 for developable surface.
And one.
Then what is the S, R and T? अभिजीत
Yes, sir.
The curvature at any point is the r, small r, 1 upon rx, 1 upon ry is the r. One upon rx is the small r and 1 upon ry is the t. And 1 upon rxy is s. 1 upon rx is small r, 1 upon ry is small t, and 1 upon rxy is small s. Okay. So, s square minus rt is equal to 0 for a developable shell. This is due to the, why s square minus rt is 0? This is due to the fact that all developable shell surfaces are singly curved, having 0 Gauss curvature, having 0 Gauss curvature. Now, synclastic shells, Gauss curvature is positive and membrane equation is elliptical. Synclastic टेबल देख रहे हैं क्या सब लोग?
Yes, sir.
डबली कर्व नॉन डेवलपमेंट में फर्स्ट इज द synclastic where yes where Gauss curvature is positive, membrane equation elliptical. Shells of revolution, then first circular dome, हेलो,
Yes, sir.
अब आ रही है आवाज?
Yes, sir.
हाँ, सेल चेंज किया उसका. सो हैव यू ड्रॉन दीज 3 figures? The dome, the paraboloid and the ellipsoid. Huh?
Yes, sir.
Yes, sir.
Then the another one is the shallow shell, SHALLOW, shallow shell. A shell may be regarded as shallow if ratio of rise to shorter side of the shell rise means rise, vertical, ratio of the rise to shorter side of the shell is less than or 1:5. सिनक्लास्टिक शेल क्या है? सिनक्लास्टिक शेल क्या था भाई?
Gauss curvature is 0.
पॉजिटिव. हाँ, पॉजिटिव मीन्स इट इज ऑन द सेम साइड ऑफ द, like this. This is the Gauss curvature. The radius of this is on the same side. Both the radius are on the same side. Is synclastic. घोड़े का सेडल देखा है किसी ने? सेडल जिस पे घोड़े के इस पे बैठते हैं अपन.
बैठते हैं, हाँ सर.
उसमें क्या होता है?
ऐसे ही रहता है.
नहीं, गलत. ऐसा नहीं रहता है. उसमें एक कर्व ऐसा रहता है, एक कर्व ऐसा रहता है और एक कर्व उल्टा रहता है उसमें. समझे?
उल्टा. एक में घोड़ा फंसता है, एक में अपन फंस जाते हैं.
ऐसा रहता है.
यस यस.
सो एक का कर्व इधर से है और एक का इधर से है. वन कर्व इज लाइक दिस एंड वन इज लाइक दिस. सेडल.
हाँ सर.
Yes. So that is the anticlastic. That is the anticlastic. Now synclastic में क्या हुआ? Shells of revolution में circular dome, paraboloid, ellipsoid. Then shell of translation, elliptic paraboloid, circular paraboloid. The same thing. Now come to the anticlastic. एंटीक्लास्टिक में गॉस कर्वेचर नेगेटिव, मेम्ब्रेन इक्वेशन इज हाइपरबोलिक. देन देर आर अगेन 3 टाइप्स. ये सब आड़ी दिख रही है. अब क्या करेंगे? सब आड़ी हो गई शायद. उसको फिर से खड़ी करना पड़ेगी. पूरी आड़ी हो गई थी, उसको खड़ी कर दो वापस. हाँ हाँ. ओके, थैंक यू। क्या जान ही रहे? हाँ चलो, हाँ दिखाइए। Can you read, Pradeep?
Yes.
Then you start reading.
The product of two
No, 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 no. From the top, Gauss curvature.
Yes, Gauss curvature, sir. Gauss curvature, the product of two principal curvatures, one upon R1 and one upon R2, at any point on the surface of the shell is defined as the Gauss curvature. ये लिखा दिया है। Singly curvature shells have one of the principal curvature is 0.
Means figure A. Figure A.
Yes, sir. Yes, sir. Figure A.
Then positive. Second one, you read next.
The singly curved shells have 0 Gauss curvature, and the term S square minus RT for singly curved shell is 0.
Then next, doubly curved shells.
Doubly curved shells have either positive or negative Gauss curvature depending on the value of S square minus RT, being less than or greater than 0.
So in this figure B, it is positive. Gauss curvature is positive. And in the figure C, the saddle of the horse, negative Gauss curvature.
Yes, sir.
आया समझ में?
Yes, sir.
Now next, synclastic. You read.
Plastic and anti-plastic shells. Both the principal curvatures of doubly curved shell may be positive. That is, the centers of the curves are on the same side of the surface of the shells. These shells are called synclastic.
Means figure B, same side.
Yes, sir.
Center of the curves are on the same side. Synclastic. Then next, you read.
In some cases, the center of two curves are on the opposite sides of the surfaces.
Means figure C.
Are called anti-plastic.
Figure C. तो अभी आ गया समझ में?
Yes, sir. आगे सर.
नेक्स्ट थोड़ा और पढ़ो. The Gauss curvature of
the Gauss curvature of synclastic shells is positive, while the same for anti-plastic shells is negative. Yes, sir.
उनका एग्जाम्पल दिया है.
Yes, sir. Domes, paraboloids and ellipsoids of revolutions. Elliptic paraboloids and circular paraboloids are same of the examples of synclastic shells. Figure 15A to C. Hyperboloids of revolution, hyperbolic paraboloids and
1.5 A to C यानी अभी जो दिखाया था मैंने शायद.
Yes, sir.
एक मिनट. 1.5 A to C देख लो. ये तीन जो बनाया अभी बोर्ड पे. हाँ ठीक है. ये 1.5 A to C दिख रहा है.
Yes, sir.
अरे ये क्या आ गया भाई? ओके, थैंक यू. ठीक है. नाउ कहाँ थे अपन? ये वाला पढ़ लिया था. नाउ 1.3. हाँ पढ़िए.
The surface of translation. A surface of translation is generated by translating a plane curve parallel to itself over another curve lying in a plane perpendicular to the former plane. Elliptic paraboloids, circular paraboloids, hyperbolic paraboloids and conides are a few of them.
अभी बताया था हमने सरफेस ऑफ ट्रांसलेशन.
Yes, sir.
Then surface of revolution.
Yes, surface of revolution is obtained to rotating a plane curve called the meridian about an axis lying in the plane of curve. Example of doubly curved surface. Yes, sir.
है ना 1.5 ABC फिर से वही है ना. द सेम थिंग यू कैन क्लासीफाई एज नंबर ऑफ टाइम्स डिफरेंट, डेवलपेबल एंड नॉन डेवलपेबल, ये भी बता दिया अभी आप. बता
सिंपली जो होगा सर डेवलपेबल होगा.
करेक्ट. और गॉस कर्वेचर याद रखना पड़ेगा, डेवलपेबल नॉन डेवलपेबल. दीज आर सम शेल्स. The name of the D is elliptic paraboloid. Figure D is name is elliptic paraboloid. Then figure E, circular paraboloid. Circular paraboloid. Then figure F is hyperboloid of revolution. Hyperboloid of revolution. लिख लिए नाम, वैसे है, मैं ये नोट्स दे दूंगा आपको. देन ये नीचे नाम लिखे हुए हैं. जी और G1 G2 hyperboloid paraboloid bounded by parabolas and straight lines. Now next, the H is the conoid. H is the conoid. क्या दिख रहा है उसमें? एक क्यूब टाइप बना है, उसमें कर्व है एक फेस पे, उस पे स्ट्रेट लाइन ज्वाइन कर दी है दूसरे क्यूब के बॉटम को. दिखा?
Yes, sir.
One on the one face there is a curve, on another face the straight line of the cube, and we join these two, so it is the conoid, CONOID. Then the cylindrical shell, the next, the span is L. The span is L. Then the conical shell, J is the conical shell. Then K is the corrugated shell. Corrugation are there, so it is called the corrugated shell.
Yes. Yes, sir.
Then the funnel, have you seen the funnel? So the last one is the funicular shell. It is in the shape of the funnel. Funnel means if you drop for some liquid, funnel. So it is on the top, it is like the funnel. So it is funicular shell. Okay.
Yes.
So these definitions may asked in the, also this classification of this, the table in the exam.
तेरी बुक में नहीं मिल रहा है जो टॉपिक आप अभी आज पढ़ा है वो.
हाँ,
बुक में नहीं मिल रहा सर ये वाले टॉपिक.
टिमोशेंको में नहीं है ये. It is not in the Timoshenko. Some
नोट्स ग्रुप में शेयर हो जाएंगे तो.
Yes. Then ruled surface. You read. We already studied the ruled surface, na?
Yes, sir. Ruled surface is one through any point of which there is at least one straight line only on the structure.
Kuna.
This is called the ruled.
Yes, ruled किया था ना अभी अपन ने सिलेंड्रिकल में, वन स्ट्रेट लाइन रूल की थी. भूल गए?
Yeah, sir.
हाँ. In the cylindrical shell, we rule the line like this along the curve, ruling the line. And in the conical also, we rule the line along a curve. It is the ruled surface. Kunal. कुणाल,
Yes, sir.
समझ में आ रहा है?
जी सर.
Then thin shells. I may ask the definition in the exam of the thin shell. So, this is the classification of the thin shell. Very thin, thin, thick and very thick. You read? Anyone? Anybody read? Thin shell. अपने सर कहाँ गए? रणबीर सर? हाँ, कुणाल रीड करो चलो. कुणाल.
sir.
You read?
Yes, sir.
You read this?
Yeah, sir. Thin shell.
Thin shell. Yes.
Thin shell is a thin shell. It is hard, sir. Kunal पढ़ रहा है? Kunal पढ़ो.
These thin shell is a curved surface whose thickness d is relatively small compared to another dimension and radii of curvature r, and r reporting r max as the minimum of two radii of curvature shell may be classified as follows.
Means D.
Very thick.
Yes. So D is the thickness and R minimum means there are two curvature Rx and Ry. Minimum of the two is the R minimum. So the ratio of the thickness divided by R minimum, these classify the shell. If it is less than 1/200, it is less than, and greater than 200 equal to 125, less than, like this. Okay. Now,
Yes.
the normally shells used for roofs are in the first category. Normally shell used in the for the structural purpose, it is of the first category. Indian Standard Code also is stipulates for D by R minimum up to 1/20 for the thin shell. Now, the next is the shallow. Shallow shell I already explained you.
Yes, sir.
What is this definition? Shells considered shallow if the ratio of the rise to the span of the shell is less than equal to 1/5. Rise to the span. तो राइस कौन सा है, स्पान कौन सा है? सिलेंड्रिकल शेल में मान लो.
Yes, sir.
Which is the rise and which is the span? If
vertical जो होगा rise होगा.
yes, this is the
Vertical rise है, sir.
this is the rise and this is the span.
Radius होगा right, sir.
और yes, स्पान ये है कि ये है, ये बताना बाद में. Which one is the span?
Daya.
Yes. नहीं दया नहीं होगा. Length होगी.
Then shell again classified as the long shell and short shell. Long shells and short shell. Thin और thick shell लिख लिया क्या? Shells are classified as thin and thick shells. A shell can be considered thin if the ratio of the radius to the thickness of the shell is greater than 20, as we saw in that table. Then long shell and short shell. Shell having ratio of radius to span R/L less than 0.6, less than 0.6 are classified as a long shell. Shells having ratio of radius R divided by span L is less than 0.6 are classified as the long shell, and greater than this are called the short shells. Okay. Then there are three theories in the shells. ये हटा दीजिए अभी फिगर. The bending theory. The number one is the bending theory of the shell. You write the definition. There may be a question in the exam. You define the membrane theory, the bending theory, general theory of the shell. So, the membrane theory you write down, bending theory and its assumption. Membrane theory does not give the true value.
So bending theory.
ना बेंडिंग बता रहा हूँ. बेंडिंग में लिखना है मेम्ब्रेन थ्योरी. आई एम डिफाइनिंग द बेंडिंग थ्योरी, but you write that the membrane theory does not give the true value of the stress resultants. Membrane theory does not give the true value of the stress resultants as we consider edges free. As we consider edges free. The value of n phi and nx phi, the value of n phi and nx phi at the edges ब्रैकेट में phi is equal to 0, phi equals to 0, at the edges phi is equal, which is not correct. In the membrane theory does not give the true value of the stress resultant as we consider edges free, that is value of n phi and nx phi at the edge should be 0, which is not correct. In order to realize the actual edge condition, in order to realize the actual end conditions, corrective line loads are to be applied. Corrective line loads, LINE, line loads are to be applied. These line loads will cause bending of the shell. These line loads will cause bending of the shells. Hence, bending theory is needed. Hence, bending theory is needed. अभी समझाएंगे आगे इसको. Now you just write down. Then the membrane theory. In the membrane theory, shell is considered as perfectly membrane. In the membrane theory, the shell is considered as perfectly membrane, infinite in extent, and it assumed to carry and it assumed to carry external loads by means of forces in its own plane, OWN, in its own plane, known as the membrane stress resultants, full stop. This theory considers two normal stress resultants. This theory considers two normal stress resultant and one shear stress resultant which are determined from three equation of equilibrium, Thus the problem is statically determinate. लिख लिया?
Yes, sir.
N5 NX अभी फिगर में बताएंगे जब सब मिल दे कैसे लगते हैं वो. यू कैन सी दिस पिक्चर. ये जूम करना पड़ेगा. हाँ ये वाला. Are you able to see? Pradeep?
Yes, sir. Yes, sir.
Yes, sir.
Please, sir.
There is a NX in the X direction. NX दिखा?
Yes, sir.
NX. Then another is N5.
NX N5.
Then shear force QX.
QX
And the
N5.
yeah. And dx and dy we taken the small, and there is a angle d phi of the radius of the shell is the A, and the forces acting like this. So these are the direction. N phi in the circular direction, nx in the radial, means this direction, x direction, nx, while the another is curve. In the curve direction it is n phi, and the shear force is nx phi. It is not here, I think. We neglect in this theory, so it is not shown in this figure, nx phi. Okay? Now assumptions in the bending theory. I think we'll finish this theory part in this lecture, and in the next class we'll start the derivation. So assumptions of the bending theory. The first, the middle surface undergoes deformation. The middle surface undergoes deformation, but all the points on the lines but all the points on the lines normal to the middle surface
Normal to the middle surface.
before deformation remain normal to the middle surface after deformation. The second point is deformation due to radial shears are neglected. Deformation due to radial shear are neglected. The third one is the shell is assumed to be shallow. The shell is assumed to be shallow, and accordingly the slope of the shell is considered small. The shell is assumed to be shallow, and accordingly the slope of the shell is considered small with some reference plane. With some reference plane. The fourth one, the curvature and changes in curvature of the surface are small. The curvature and change in the curvature of the surface are small. The fifth one is the stress resultant Nx, n phi and Nx phi. Stress resultant Nx, n phi and Nx phi primarily carry the surface load. Primarily carry the surface loads. The sixth one is, I may ask this question. You define the bending theory, membrane theory and assumption in the bending theory. So, the sixth one is the transverse deflections are much greater. The transverse deflections are much greater than in the plane deflection. The transfer deflections are much greater than in plane deflection. In plane. Okay. So, I think it is enough for today. कोई है कि चले गए? लिख लिया डेफिनेशन वगैरह? तो आज थोड़ा थ्योरी पार्ट अपन ने पढ़ लिया है. फ्राइडे को विल डू सम derivation. In these shells there are main two derivations are there. You can see. हाँ, कौन पढ़ेगा? Last two questions. Can you read? Can you read? Anybody?
Yes, sir.
Question number 7.
Question number 7, sir. Show that the differential equation for the circular cylindrical shell are constant thickness when loaded symmetrically with respect to its axis is given by. Del step 4 upon del d4 w upon dx square plus 4 beta is equal to z by d.
And question number 8.
Question number 8 is to define the following equations of equilibrium in the case of shells in the form of surface of revolution and loaded symmetrically with respect to their axis.
Okay. So, in the next two classes, we will do the one in the one class and another in the another class this derivation, and that will finish your course. So, I need 2 more classes.
Yes.
Okay.
Yes.
So, next is on the Friday immediately, na? The next class is immediate.
Yes.
day after tomorrow and the next on the next week. Okay. बंद करिए. ये पेन ड्राइव निकाल लूँ क्या मैं?
Thank you, sir.
ओके.
पीपीटी यूज की थी सर?
Recording
वो
stopped.
बोल रहे थे पीपीटी का.
Okay, sir.
ओके ओके ओके.
Thank you, sir.
पीपीटी नहीं, मेरे को कुछ दिखाना था फिगर. हाँ वही किया पेन ड्राइव से.
आप बोले तो सर इसको सेव कर देते